And this paper involves two of my students. João Soliman is a master's student. He's just finished his dissertation. Juliana Baldalfi is a PhD student. And this work has been developed in collaboration with Professor Patricia Tsortsopoulos from the University of Huddersfield. So this work is about managing client requirements. It provides an overview on how client requirements can be modeled to support decision making by using BIM. I'm going to report some ongoing studies and point out some opportunities for further development. There are two basic motivations for develop this work. First is that, well, there has been many initiatives for implementing Lean in healthcare. I think this is one of the main areas for Lean implementation. But we don't see a strong connection between the built environment and the improvement of Lean, the improvement of healthcare processes using Lean approach. And the other motivation is that, of course, healthcare facilities are very complex for different reasons. There is the structural complexity, large number of subsystems, a large number of interdependencies. If you think of the final product, the hospital, a hospital, for instance, it has several units within a hospital, and those units are also interconnected. You have many stakeholders with different requirements, like the facilities managers Iris mentioned. You have a large number of design professionals because there are many subsystems. And then you have the uncertainty component of complexity. So healthcare processes, they change very often. There are new technologies, new strategies for providing healthcare services. Sometimes you start a project, start a design of a building, of a healthcare facility, and in the middle of the design, the way this facility is going to work changes, and then you need to change design. So in this context, it is an opportunity to improve value generation by explicitly managing requirements. What is requirements management? So you have to identify requirements, you have to analyze them, you have to set priorities, you need to make this information available to the decision makers, and then you can use that information also to verify design solutions. It's not an approach in itself, but you can use with other approaches. It can support, for instance, design reviews. It can be a source of evidence for design, so it's connected to evidence-based design. You can use in certain managerial approaches like benefits realization, which has been used in the UK. There are some studies, previous studies on house building, especially for low-income projects in which value generation is a key topic. And in house building, it's mostly based on post-occupancy evaluation. So you evaluate previous projects, and then you can use those requirements for designing new projects. There are not many studies in the healthcare context. So which kind of requirements do you need to manage? So there are different types of requirements. There are requirements that are captured directly from the users. There are requirements that are already formalized through legal instruments. For instance, most countries have healthcare regulations for facilities, fire codes, codes related to energy efficiency, accessibility, and so on. In each of those topics, you have a relatively large number of requirements. And there is another type of requirement that is very important in healthcare facilities. We call that process requirements. It's a kind of requirement that you don't take directly from people, from users, but you need to understand some critical processes in the facility so you can actually understand the requirements. So how do you manage that? You can bring people to meetings. That's, of course, very important. In some projects, people bring lists of requirements, something like a brief for the project. And in such a complex project, this can be quite long and difficult to work with. So the idea is, part of requirements management is to model requirements. So you convert this information related to user client needs and expectations. This information is not very well structured. So you represent this information in a way that it can be better understood, it can be better manipulated, it can be better managed in the design process. So that's the basic idea. So instead of having a list, you can have a structure for the requirements. One possibility is to use that to negotiate requirements. For instance, you call the 10 facilities managers, and then you do some kind of work with them and mediate the discussion, and then you can formalize those requirements. There are some IT tools available. There are IT tools for mapping requirements, and of course there are some BIM tools that can also be used. And those BIM tools, they're very good because you can connect requirements to a product model. This is a map of requirements for a house building project, and this is a very comprehensive map of requirements. So you have requirements that are very operational, right? They are mostly connected to the product attributes, and the combination of those more operational requirements makes you understand how the more abstract values are formed. For instance, at the top you have quality of life, you have well-being, you have family integrity. So this is high-level values for house building. So in this specific project, the healthcare project, we are working more at the bottom level. So we're working more with requirements that can be connected to product attributes. So these are more technical requirements, different from the ones at the top of the hierarchy. We've been involved in an empirical study. This is a university hospital. It's from my university. It's it's actually a healthcare complex. It has several hospitals, several buildings, and it's going to be, and this complex is being extended. The area is going to be increased in 70%. It's already a big hospital complex. Just to give you an idea, 6,000 people circulate in this complex every day. Unfortunately, when we started to work in this project, the design has been concluded. They were already building the two buildings that are in this construction project, but still, it was useful to do this study. I'll explain later on. And our focus was in one of the units of the hospital, which is the emergency unit, a very critical one. There are some peculiarities about this type of hospital. First, one of the aims of the hospital is teaching medical students. So there are some additional requirements related to teaching. And also, this emergency unit is very different from other ones because it's a state hospital, so in a way this emergency unit compensates problems that we have in the healthcare system. So it's a very big emergency unit much bigger than in other hospitals. Okay? About the research design, so very briefly, we started identifying, understanding the requirements, the regulations. We structured the requirements, model those requirements, and then we modeled the existing design, and using some BIM softwares, we connected the requirements to the design. And at the end, we did an assessment of the design in relation to a set of requirements. So this study was divided in two types of requirements. One of the studies was about what we call legal requirements, and it was based on the main Brazilian regulation for healthcare facilities. We identified 1,284 requirements from that regulation, and directly from the users, we identified 177. Very briefly, which kind of results we got, which kind of data we worked, and which kind of results we got. So this is the one about the user requirements. So we start creating a table in which we establish categories and subcategories of requirements and count the number in each category and subcategory. This is very important because it's the first stage for processing information. So this is very important for structuring the information so you can make it easy for people to understand. And this is the software we use. It's called Rufus. It's a Norwegian software. It's very good, for instance, for allocating areas in the building for specific uses. It's good for connecting areas, defining which connections are more important. You can put lots of qualitative information in that software directly connected to the building model. And this is an example of the kind of data we got, right? The main categories of requirements. You can see, for instance, that there are many requirements. When you capture requirements about the built environment, it turns up that you have many requirements related to furniture, equipment, visual requirements. So it's something that we have to deal with. It's not only requirements of the building, but of the let's call extended built environment. So it's the building, the furniture, equipment that is going to be installed after the building project is ready. It's very difficult to separate that. Some of the results we got, so considering all the requirements that we identified, 31% where the design fulfilled those requirements, 5% partially, and 11% of the requirements were not fulfilled by the design, right? But it's important to point out 54% we could not define at that time because many decisions about furniture, equipment, visual artifacts had not been defined. Some insights, this kind of modeling is very good not only for the early stages of design, but you can also use at the moment when they are going to define, they are going to buy the equipment, they are going to buy the furniture. And that's a large project as well. It's very, very expensive, sometimes as expensive as the hospital itself. I'm going to point out a few things. Of course, this kind of thing, as we did late in the project, created some conflicts. Not created, exposed some conflicts, because the medical staff hadn't participated enough of design decisions. Okay, just 2 minutes. This is the other work we did, which was modeling legal requirements using Solibri Model Checker, which is a well-known tool. We did the same thing. We tried to categorize requirements. For instance, only part of the regulation could extract requirements. Some of the regulations were not useful for requirements, and we found out that 2/3 of the requirements could be transformed in rules, coded rules for automated checking, right? So part of the legal requirements cannot be automated checking. Some insights. I'm going to go to the end. So the conclusion, there are different approaches for modeling requirements. We can choose a combination of those approaches. There are some software packages that can be used, but they provide fragmented solutions. They can be used only for part of the requirements. Another insight, requirements modeling can be used for different stages in the project, not only at the beginning, at the briefing stage. There are some limitations in automated checking for both types of requirements. And developing taxonomies of requirements were very useful because, again, as I mentioned before, this is the first way of processing information, of organizing information. And finally, we felt that there is an opportunity for improving client requirements if you have a proper theoretical framework on how information is transformed. One of the questions I asked my student was, how come you have 1,842 requirements? If there was somebody else doing that work, maybe this number was going to be different. So it's very important to have some clear concept of what is a requirement, how you transform regulation in requirements, and so on. Thank you very much.